If we take first member BD, we conclude that it's a two-force member. Then the force at B should act along line BD, and we assume that it is upward. And now by principle of action-reaction, when I take member ABC, okay, the force will be equal and opposite, so it will be downward. Since it's acting along BD, and you have here the angle for BD is 45 degrees, because you have, this is a isosceles triangle, which is a right triangle also. So 0.2, 0.2, this is 90 degrees. So I have 45 by 45. So now I know the direction of F. The only unknown is its magnitude now. Okay. In addition, I have the reaction at A. The reaction at A is divided into two components, AX and AY. So now if I do the analysis for ABC, I have three equations with three unknowns. But if I look well also at my figure, I can benefit from another information. If I look well at my figure, when I consider member ABC, member ABC is weightless and is subjected only to three forces, one at A, one at B, and one at C. Okay, so what I conclude that it is a three-force member. So ABC is a three-force member, and therefore, what can I say? I can say that the three forces should pass by O, by one point. Okay, what is this point? I will find by geometry what is this point. The 400 Newton force is horizontal. For F force, I know the direction. It's doing a 45 degrees with the horizontal. And I will name the intersection point, I will name it O. Now, I can say that to have equilibrium, what is the condition? The condition is that FA should pass by O. Okay? So now, this information will allow me to know the direction of FA. Because if you look well at your figure, FA should pass by O, okay? And the distance from here to here is 0.5 plus 0.2. This distance is 0.7, okay? And this distance here is also can be calculated. It's equal to 0.5 minus 0.1, it's equal to 0.4. So this distance is 0.4. So now I can say that I can calculate this angle, which represents the direction of FA. I can say that tangent of theta, tangent of this angle, is equal to 0.7 over 0.4. So what I did now, I reduced my systems from 4 unknowns to only 2 unknowns, which are the magnitude of F at B and the magnitude of the force at A. And to find these two forces, all I have to do is to write two equilibrium equations. I can choose any two equations I want. So the easiest one here are sum of x equals 0 and sum of y equals 0. If I do sum of x equals 0, what do I have? Along x, I have plus 400 Newton minus f cosine 45, because if I project this force on x, it's minus f cosine 45. And for FA, if I projected, I should do FA cosine angle theta. Okay? And theta is already calculated, so I find the first equation. The second equation, along y, I do not have any force other than F and FA, okay? Because the 400 Newton is horizontal. So I have the component of F is negative, it's minus F at B cosine 45, and for FA it's plus FA cosine theta. So now, when I wrote these two equations, I have two equations with two unknowns, which are FA and F. Okay? Now, if I didn't notice that I have a three-force member, if I didn't pay attention, what can I do? I can simply say I have two unknowns here, AX and AY. And the third unknown is F. So I should write in this case 3 equations instead of 2. So if when I notice the 3/4 member, I can reduce the number of equations. And if not, I should do sum of x equals 0, sum of y equals 0, and for example, sum of moment about a equals 0. Then I will get ax, ay, and f. And I can, then when I find ax and ay, I can say that fa is radical ax squared plus ay squared. And it's directed to find the angle. I can say that tangent theta is fay over fax. But it will be a longer solution. Okay? And if I didn't notice at all the 2/4 member also, and if I didn't use the concept of the 2/4 member, it will be much more complex. Why? Because what I will have I will have 6 unknowns. If I didn't notice here that I have a 2/4 member, I will have 6 unknowns, which are, I will have unknowns ax, ay, bx, by, and dx, dy. So I should write 6 equations in this case. What will be the 6 equations? When I take the member BD, okay, I will put forces. I will put, let's say, I assume I have bx, by like this, let's say, and dx, dy like this, okay? So these are my unknowns here. I will write sum of x equals 0, sum of y equals 0, and sum of moment about any point equals 0. I will get the first 3 equations. Now, when I move to member ABC, by action reaction, if I choose here bx, by like this, here they should be opposite. So I will put bx, by in the opposite direction here, and I will add ax and ay. And for this system here, I will write also 3 equations. So I end up with 6 equations with 6 unknowns. So you can see here, by paying attention for the 2/4 member and the 3/4 member, I can reduce a lot of time in the solution. And sometimes it's impossible to solve without the concept of 2D and 3D. It will help me a lot to reduce my unknowns. Okay? Any question? So we will continue next time. Thank you.
Thank you, Doctor. Bye.
Thank you,
Aman,
doctor.
yes, Aman, you can talk to me after when the session ends. Yeah. So tell me. Let me stop recording first.